Now, let's sketch these three random variables on a single plot. So I'm going to draw this horizontal line to represent the range of these random variables. Random variable A has an average of 100 and standard deviation of 10. So let's say that here is 100. And because this random variable has standard deviation of 10, if we want to draw this graph, we would have to stretch the bell curve from mu minus 3 sigma to mu plus 3 sigma, right? So doing the same, mu plus 3 sigma for this random variable would be 110, 120, and 130 is mu plus 3 sigma. And mu minus 3 sigma would be 90 here, 80, and 70. And this random variable would have a distribution like this, right? So this is random variable A. Random variable B has the same average, but a different sigma. In this case, sigma is equal to 5. Well, comparing A to B, what is the difference here? Well, B has less variability compared to A. So it's going to be a narrower distribution around the same mu. In this case, the mu plus 3 sigma would be 115. Mu minus 3 sigma will be 85, right? So 1 sigma, 2 sigma, 3 sigma, 1 sigma, 2 sigma, 3 sigma. Here it would be 115. Here it would be 85. So random variable B would have a PDF function that stretches from 85 to 115. And the area under the curve should be equal to 1, same as the area under this curve. So the peak of this random variable would go higher to accommodate the same area under the curve. So this is random variable B. And random variable C has a different mu and standard deviation of 10. So the average of this random variable would be placed at 80. And mu plus 3 sigma here would be 110. Mu minus 3 sigma would be 50. So 110 and then 70 and then 60, 50. So 60 and 50 here. So this random variable would stretch from 50 to 110. So random variable C would have a PDF like this. So here you can see the differences between these three random variables in terms of their the impact of mu and standard deviation on the shape of these normal bell curves or PDF functions of them. So let's assume that this A, B, and C are three different cities and they represent the temperature of those cities. Okay? So for example, city A has an average temperature of 100 degrees and it goes all the way up to 130 and it goes down to 70, during colder seasons and warmer seasons. If you were to pick a city to live in, which one would you pick? Well, it's a matter of personal choice, but I would probably go with city C, right? Because the average is 80, which is, tolerable. A little warmer than I would like, but it changes from 50 in colder seasons to 110 in warmer seasons. If you are a person that would like consistency in the temperature, you would go to city B, right? Because the difference between warmer and colder seasons is not that much. It's more consistent around 100 degrees. So this is one way of giving you an example that you can relate with in terms of normal distribution.